Hi learners. In the chapter Application of Derivatives, today we shall study the topic Tangents and Normals. Perchance you may think that tangents and normals may be related to geometry. Yes, of course. But calculus can deal with tangent and normals in a very advanced way. We know that derivative of a function at a point means the slope of the tangent drawn to the curve at that point. Here you can see the function f given by fx is equal to x squared by 2 minus 3x plus 8 and a point capital A. And we know the coordinate of A and the slope also we know. Slope is nothing but a derivative. So knowing the function we can find the derivative that will be the slope at that point capital A. Then we can write the equation to the tangent as y minus y1 is equal to m into x minus x1. That can be simplified. And the green colored line now at A, but it is perpendicular to the tangent. That is what is called the normal to the curve at capital A. Then we know that tangent and normal will be perpendicular. Therefore, the product of their slopes will be -1. That you learned in 11th class. So, we can have the slope of the normal as a -1 by m. So, its equation will be y minus y1 is equal to -1 by m times x minus x1, which could be simplified.
See here we have drawn the graph of the given function given by fx equal to x squared by 2 minus 3x minus 8. That is a parabola. We have taken a point capital A on the parabola whose coordinates are 4, 4. Then you can see from the diagram the slope of the line, that is 1. You know in geometry also you learned it. This angle being 45 degree, tan 45, that will tan 45 degrees, that will be the slope. So you can find it somehow, but calculus can find the slope, how it is. That is very interesting. You take the derivative of the function, that is f dash x, that is equal to here what is it, x co-derivative 2x by 2 means x only, then x minus 3. Then you evaluate that derivative at capital A. What is capital A? 4, 4. So you have to substitute those coordinates in the obtained derivative, that is 4 minus 3 means you can have that is 1. Is it interesting? So we could find the slope of the tangent. Once you know the slope and point, you know point capital A 4, 4, then you can use this equation for finding, that is y minus y1 is equal to m into x minus x1. You can use this equation to write the equation to the tangent, that is y minus 4 is equal to slope is 1 only, that we computed already using calculus, into x minus 4. So which gives you y minus 4 is equal to x minus 4, which could be simplified to get y is equal to x. So this way we can compute the equation to the tangent. And if you choose a particular point, say capital A, in general form, that is x naught, y naught, then you see what is the slope. Then slope could be written as f dash x naught. In such a way, the equation to the tangent could be written as y minus y naught is equal to f dash x naught. Why f dash x naught? That is the slope, into x minus x naught. So using this equation we can find the equation to the tangent. Now let us draw a line which is perpendicular to the tangent at A. That is this green line. This is what is called normal to the curve at capital A. Then how to find its equation? So we have to find the slope of the line first of all. So we know m is the slope of the tangent at A, and let capital M be the slope of the normal. Then these two lines are perpendicular. Normal is perpendicular to the tangent. Then there is the relationship m into m, product of their slopes should be -1. That you learned already in 11th class geometry. So using this, you can compute the slope of the normal as 1 by m if m not equal to 0. That's very important. Otherwise we can't divide by 0. So we can find the slope of the normal using this formula -1 by m, where m is a non-zero quantity. Then using the equation to point the slope form, we can write the equation to the normal like this: y minus y1 is equal to -1 by m into x minus x1. Then we can simplify to get this equation. How to simplify? That's very simple. You see here m is equal to 1 only. M is equal to 1 only. We can find it using calculus that we learned already. And here then capital M will be -1 by 1. That is equal to -1. So then y minus y1. y1 is 4. Slope is -1 for the normal. Then into x minus 4, which could be simplified as y is equal to -x plus 8. This way we can compute the equation to the normal at A. So in general we can say if the point is capital A, x naught, y naught, then equation to the normal could be written as y minus y naught is equal to -1 by f dash x naught into x minus x naught. Now let us consider another case. Here we have taken the point capital A, that you can see from the diagram 6, 8, 6, 8. So 6, 8 the coordinate of capital A. Then again we can compute the slope of the tangent, that is m. So here m is nothing but derivative value at capital A. That is x minus 3 is the derivative value, and we have to put 6, 8. Here there is no y, so we need not substitute it. Only x is in the derivative, so we have to substitute x equal to 6. So 6 minus 3, that is equal to 3. So slope is 3. So the equation will be y minus y1 is equal to m into x minus x1. That is y minus y1. y1 means 8 is equal to slope we computed just now. So what is the slope? Slope is 3. So 3 into m into then x minus 6. That is the x coordinate. That you can simplify y minus 8 is equal to 3x minus 18, which could be further simplified as y is equal to 3x minus 10. So this way we can compute. Then how to get to the equation of the normal at A? We can utilize this equation for that. That is y minus y1. So y minus y1 means, that is 8. Y minus 8. Y minus 8. Y minus 8. Then slope. Slope is -1 by m. M means we already computed 3 into x minus 6. That can be simplified as y equals -0.333 means you can write -1 by 3, no problem, into x minus 6. So you can simplify it to get the equation to the normal. Now let us solve a problem. Find the slope of the tangent to the curve y is equal to 3x power 4 minus 4x at x equal to 4. So I told you slope is nothing but derivative of the function at the given point x equal to 4. So what is it? What's the derivative? Derivative is 3 into then 4x cube we have to write minus 4. And we have to evaluate this expression at x equal to 4. So that is 12x cube minus 12x cube minus 4. We have to evaluate at x equal to 4 only. So you can do it. That is 764. This way you can. How it is? That is 12 into x means 4 cube minus 4. Then you can simplify to get 764. That is the value of the slope of the tangent. Find the point at which the tangent to the curve y is equal to x cube minus 3x squared minus 9x plus 7 is parallel to the x-axis. Here we have to find the points at which the tangent to the curve is parallel to the x-axis. Means tangent should be parallel to the x-axis. Now you can see this is the graph of the given function, given that is fx is equal to s cube minus 3x squared minus 9x plus 7. And here the requirement is that there are points on the curve at which a tangent is parallel to the x-axis like this. Means we have to find this point and this point. Tangents are parallel to the x-axis at those points. We have to find those points. So how to find it? So here again I told you we can find the slope of the tangent by taking the derivative. So what is the derivative here? That is f dash x is equal to 3x square minus 6x minus 9. Calculus says this is the derivative at any point xy. And you know, when tangent is parallel to the x-axis, what is the slope of the x-axis? Slope of the x-axis is 0. So this tangent is parallel to the x-axis means here also and here also slopes should be 0. Therefore, f dash x, the slope of the tangent should be 0, which implies 3x square minus 6x minus 9 is equal to 0. You can simplify it also by taking 3 common factor outside, that is x squared minus 2x minus 3 is equal to 0. So which implies x minus 3 into x plus 1 is equal to 0, which gives you the x coordinate as 3 and x coordinate as -1 at those points. So clearly from the graph here the x coordinate will be 3 and here the x coordinate will be -1. Then how to find the y coordinate? We have to find those points, no? So we go to x coordinate only. Calculus is giving the answer always in a compact way. We have to find the y coordinate using the given function. That is, in order to find the y coordinate, what we have to do is we have to substitute the x value. Here x value is 3 in the first case. That is f of 3 you have to compute. That is 3 cube minus 3 into 3 square minus 9 into 3 plus 7. That you have to simplify. Then you can get that is -20. So this point will be 3 -20. That is the one point. Similarly, you have to compute f -1. So f -1 you have to compute. F -1 also similarly you can compute, that you can have 12. Therefore this point will be -1 12. So the points on the curve are -1 12 and 3 -20 at which the tangents are parallel to the x-axis. Another question is, find the point on the curve y is equal to x cube minus 11x plus 5 at which the tangent is y is equal to x minus 11. This time you see the tangent is given, then we have to find the point at which this line becomes a tangent. We have to find a point on this curve. At that point, the tangent should be y is equal to x minus 11. Now let us see what is happening. So you can see the curve and the given tangent here. So we have to find this point. That's our target. So again, from this line, you know y is equal to mx plus c. When we compare it as y is equal to mx plus c, then you can find the slope of the given tangent, that is 1 only. Now according to calculus, how to find the slope of the tangent? So here we are given the function, so we have to find the derivative f dash x, that is nothing but a 3x squared minus 11. And for this tangent, slope is already known and slope is given by calculus. So they should be equal. Therefore 3x square minus 11 should be equal to 1. So which gives you x square is equal to 4, that is x equal to plus minus 2. Thus we got the x coordinate as a plus 2 and a negative 2. We have to find the corresponding y coordinate by using the given function x cube minus 11x plus 5. So we have to find it, that is 3x cube. S cube means when x equal to 2 we are going to compute. So when x equal to 2, y becomes 2 cube minus 11 into 2 plus 5, which gives you negative 9. And when x equal to negative 2, we have to compute, that is negative 2 cube minus 11 into negative 2 plus 5, that will be 19. So we got both the points, that is first point is 2 negative 9 and second point is what we can say negative 2 19. But you can see that this point should be on the curve as well as on the given tangent. So here you can see that the second point is not satisfying the given equation y is equal to x minus 11, showing that this answer should be rejected. So this is the record point 2 negative 9. That is at this point, you can see it, that is at the point 2 negative 9, this blue colored tangent, that is y is equal to x minus 11. And the second answer negative 2 19, that is not admissible because negative 2 19 doesn't satisfy the given tangent equation. So only one point we have, that is 2 negative 9 on the curve, at which tangent equation will be y is equal to x minus 11. Find the slope of the normal to the curve given by x equal to 1 minus a sin theta, y is equal to b cos squared theta to theta is equal to pi by 2. Here the function is given in parametric form. So we have to find dx by d theta, dx by d theta. What is it? That is derivative of 1 is 0, then negative a constant as itself, then derivative of sin theta is a cos theta. So we have dx by d theta. Then we have to find dy by d theta. We have to find dy by d theta. Then again that is symbol b into, then cos square means 2 cos theta, then into negative sin theta. We are applying chain rule here. So that is negative 2b sin theta cos theta, negative 2b sin theta cos theta. Then we can find dy by dx by the formula. What is it? That is dy by d theta whole divided by dx by d theta. So that is equal to negative 2b sin theta cos theta divided by negative a cos theta. So you can simplify, that is by cancelling cos theta, negative, negative. So we are left with 2b sin theta by a. So this is your dy by dx. And we are given the point theta is equal to pi by 2. We are given the point theta is equal to pi by 2. So we have to evaluate dy by dx at the given theta value, that is pi by 2. That will be the slope of the tangent. That will be the slope of the tangent at theta is equal to pi by 2 on the curve. So we have to evaluate it. That is 2b sine theta divided by a. We have to evaluate when theta is equal to pi by 2. That is very simple, because when theta is equal to pi by 2, sine theta becomes 1. So we have 2b by a. 2b by a. That is the slope of the tangent. But the requirement is slope of the normal. Requirement is slope of the normal. So how to find it? We know that tangent and normal are perpendicular. Therefore, their product of the slopes should be -1. And we know the tangent slope that we could find, that is 2b by a into slope of the normal, that is -1, which gives you slope of the normal m is equal to -a by 2b. So that is the requirement. Okay learners, that's all for now.